Over the past decade of working with backend JavaScript to talk to databases, I have used many different ORMs, including things like SQLize and also Waterline.js, and also query builders like Connects.js, and then the ORMs based on top of that, like Bookshelf.js and Objection.js. But eventually, in the world of JavaScript, there was a push towards type safety with TypeScript, and so libraries like TypeORM popped up. And also Keysly, which is a query builder similar to Connects, but it has type-safe queries for like your table names and column names. And then eventually, all of these libraries also adopted TypeScript, so you could get some level of type safety, including Connect. So you can actually create interfaces for your tables and get more type safe queries. And I have apps running in production that have used all of these libraries, including Prisma, which is the more modern choice for working with databases in TypeScript or JavaScript. And for good reason. Prisma has a very nice way of defining your schema. It's fully type safe. Also, the query language is nice to work with most of the time. And it's a great library, but there are certain scenarios where it starts to break down, especially when trying to run Prisma in a serverless environment where you might have memory or size constraints. And then sometimes Prisma generates multiple queries in situations where maybe a single query would be better. So it does have its issues. Enter Drizzle. Now, there's been a lot of hype around Drizzle, but I have been working with Drizzle over the past week to implement a fairly complex schema. And I like it. I really like it a lot. And ultimately, I see it as kind of the culmination of all of these ideas in working with databases in backend JavaScript. And it does everything really nice. So the type safety is awesome. It's tiny, so it has no dependencies. It works really well in serverless environments. Also, the query syntax is very interesting. So they have two different kinds of syntax you can work with. They have a more Prisma ORM-like syntax, but they also have a query builder syntax. And finally, it's performance. So I'll show you some of the queries that it generates. And it's kind of fascinating how it can take your really complex ORM-like code and just generate a single query from that. So it's awesome to work with. So in this video, I'm going to show you how I implemented this complex database for an application called bytedash. So essentially, this is like a food delivery app. It has users. It has restaurants. Restaurants have menu items. Users can make orders and then they add menu items to it. So there's a lot of complex and nested relationships going on here. So I really put Drizzle to the test. And in this video, I'm going to kind of show you some patterns that emerged in a more complex Drizzle code base, including defining your tables in separate files when you have a lot of different tables in your schema. Also, how to create a single database connection in a single Drizzle instance that can be used whether you're migrating or seeding or running your code in an actual application. Also, I'll show you how I created seeds for nested and related data, because that gets pretty tricky to do once you have this many tables to work with. And of course, I'll show you all of the schemas that I have created and what it looks like when you have more complex schemas as well. So like the order table has a restaurant, a user, a driver, an address. So it gets pretty interesting. And finally, I'll show you the query syntax as well. So like I mentioned, you can do things that are more ORM Prisma-like, but there also is a query builder syntax. So for instance, this query here written as a query builder with joins would look like this. So I'll show you this. I'll show you the queries that get generated. And I had a lot of fun coming up with some much more complex queries, a lot of them that kind of combine the ORM syntax with the query builder syntax. So it's good stuff. If this interests you, stick around and let's do it. So my name is CJ. Welcome to Syntax. Now, when you visit the Drizzle docs, you'll see that they support three different kinds of databases: Postgres databases, MySQL, and then also SQLite. But they take a very different approach than I've seen with other ORMs in that, for instance, if you're connecting to a Postgres database, it's going to vary the type of Postgres database in this modern world of like hosted services and things like that. So depending on the type of Postgres database that you're connecting to, you will choose a specific Drizzle driver for that database. And so they've created these Drizzle drivers for all of these different kinds. And also, if you, for instance, choose MySQL, they've created drivers for like PlanetScale and also like a direct MySQL database, and then also SQLite. So with things like Terso, or when you're running SQLite in a specific type of environment. So this is a very different approach than I've seen with other ORMs, but ultimately I think it allows them to create more performant queries and do things in a specific way depending on the type of database and service that you're connecting to. Now for my application, I'm just doing Postgres. So I chose the Postgres.js driver. I have a Postgres database running locally in a Docker container, and then when I deploy the app, it's just Postgres running in the cloud. Now, all this code that I will show you is completely open source. So the link is in the description. You can peruse this code, you can dive into it and kind of learn and steal some of the patterns that I've come up with here. First of all, we're connecting to a Postgres database. So if you're not using Docker to run Postgres locally, you should. So here's a simple little file that you can use. You literally just copy paste this into your app and you can get a Postgres database running locally. All you have to do at this point is just say docker compose up. And now we have Postgres running on my machine, which is great. So steal that and use this in your own application. From there, we have environment variables, right? So I have a .env that has all of the information for how to connect to my database. But this is a TypeScript application, so I want a type-safe way of working with those environment variables. So I'm using Zod for that. So if we take a look at my env.ts file, we're using Zod to create a schema that essentially makes working with our env type safe. And it basically pulls in all of those environment variables and then makes sure that they're valid, and the application will not start if your env is not correct. So this is another pattern that you can steal. There are some libraries out there that help with this, but just using Zod directly is not too bad. So you can take a look at this file, but basically anywhere I need these environment variables, I'm using this file, which first parses it from the env file. From there, we create our database connection. Now, I talked about this, but you will bring in the specific Drizzle connector based on the type of database that you're connecting to. So for me, I'm using a Postgres database, so I have Drizzle ORM /Postgres-JS. So this is how I will create my Drizzle instance. And then that corresponds to the actual Postgres library. And so that's how I'm creating my database connection. Now, in the documentation, it can be a little bit confusing because they actually show you. So let's say you choose Postgres and then you go in here to Postgres.js. They have some code that you can copy paste here that has a specific connection for migrating and a specific connection for when you're just querying the database. I didn't want to have that because that would be like code duplication. So essentially what I've done is I have this single entry point. So I have a DB folder. Inside of that, I have my index.ts, and this is where I create both of those things. And then I have some environment variables that set the options depending on where we're running. So if we are migrating or we're seeding, we set the max connections to 1. And so this is specific to Postgres, but you might have other things that you want to set specifically when you're migrating or seeding. But in this case, we don't want to have multiple connections because we want to create the tables in the correct order and also seed the data in the correct order. So when we're migrating or seeding, single connection. Otherwise, as many as you want. Use a connection pool so that way your queries across your app are more performant. And then specifically when we're seeding the database, I'm doing some truncation of tables. So I wanted to kind of hide those warnings and notices that pop up. So I disable those here. And then from there, we just pass that connection into the Drizzle instance, and then we can use this Drizzle instance anywhere we need to query our database. Now for the schema, you can see I'm importing everything from this DB schema file. So let's take a look at that. So if you look in the source DB folder and then in schema, we have an index.ts file, and this imports every single table and every single relation associated with that table. So before we dive into my schema files, let's take a high-level overview of this overall database structure. So it all starts with users. We have users of our application. Now, a user can also be a driver, and so the driver has a user ID, which is a foreign key. And then users can have many different addresses. So if you think about it, maybe sometimes you want to deliver the food to your house. Maybe sometimes you want to deliver it when you're traveling, or maybe you want to deliver it to work or something like that. So a user can have many addresses. Now, an address has a city ID. And so there's a lookup table for cities, and then a city has a state ID. And so for this application, it's just US based. Things get much more complicated if you want to support addresses for different countries, but we're imagining that this application only works in the United States. From there, we have restaurants. Now, a restaurant, we're actually just embedding the address in the restaurant table. In a more complex app, you might actually have a restaurant table that has maybe a join table for addresses. Let's say you have multiple locations in a single city. You probably don't want to duplicate that restaurant information. So there's other ways to do this. I simplified it by just storing the address directly on the restaurant, but we do have that city ID. So that way, when someone is searching for restaurants, the user, we can use their specific delivery address city ID to look up those specific restaurants. From there, a restaurant can have many menu items. Then each menu item can have a category. Now, this is actually where I'll show you Drizzle Studio, so we can actually take a look at this lookup table here. Now, Drizzle Studio runs in the web browser, and it lets you inspect your tables, insert data, that kind of thing. And so to use it, you're going to need a config file. And so in the docs, they have a way that you can copy paste that in, but let me show you how I set mine up. So if we take a look, it's at the root here. It's called drizzle.config. And you can see that we're importing our schema from that same common location that we imported it when we were setting up the Drizzle connection. Also, I'm putting my migrations folder specifically in the DB folder. So you can have them at the root, but I like to consolidate all of my DB stuff into this folder itself. So Specifically, I want my migrations to exist in this folder here. Now, we specify the driver as Postgres, and then we can specify our connection URL. Now, again, I don't want data duplication, so we're pulling in that environment variable from that typesafe env. From here, because this file lives in the root of my code base here, if from the command line I do an npx drizzle-kit studio, that will launch Drizzle Studio. And so Drizzle Studio will let you dive into all of your tables. You can also like add records. It's a nice way of interacting with your database when you're in development. But for instance, we have this category lookup table. So a menu item can be an appetizer, a lunch, a dinner, a salad, etc. But then we also have a lookup table for like our states, right? So these are the states that we support. And then we have a lookup table for cities. So these are the cities that we support as well. From there, we have orders. So a user can place an order, and that order is going to have a delivery address. So there's a specific address that it's going to be delivered to. We have the user that placed the order. And then once the order is in progress, we have a driver that's going to get assigned to that order. Now, a driver just relates to the user table, but it has specific information about like the car that they're driving and whether or not they're online and available. And then an order has many menu items on it. So for any given item that gets added to the order, we insert a row in this table here. But then we actually take a snapshot of the price and the quantity, because it's possible that later on a restaurant owner might change the price of a menu item, but we want historical information about how much a user paid for that specific menu item when they placed the order. So that's why we're duplicating that data here. But basically, an order is going to have many of those menu items. And then an order has an order status. So if we look back in the database, the status catalog is kind of the lookup table here. So an order can be in any one of these states. So it can be new, confirmed, preparing, ready for delivery, out for delivery, delivered, or canceled. And so an order goes through many different statuses. So it's going to have an entry in this join table here, this order status, for every time that status changes. And so that way you could implement something like a delivery tracker that shows exactly when these various events happened. And that's our database. As you can see, some things are normalized, some things aren't. It could be more complex, but I think this was sufficiently complex to really put Drizzle to the test. And so let's see how some of this stuff was implemented. Now let's take a look at the user schema. So in source DB schema, I have user.ts, and this is where I define the user table. Now you'll notice that I am importing from Drizzle ORM PG core. And so when you look in the Drizzle documentation under column types, you're going to want to make sure that you choose the specific kind of database that you're connecting to, because if you're defining a schema for a MySQL database, you're going to want to import from that specific library. And also they have one for SQLite. So because I'm using Postgres, I import from PG core. Now, you can see when I'm defining these columns, we can have this kind of like chained method to define our constraints. So for one, when you're working in Postgres, if you want to define an ID column, they have this serial type that makes it auto incrementing. And then they also have the primary key constraint. For all of my other columns, you can see most of these have the not null constraint. And then for some of them, they need to be unique, like phone number should be unique and email should be unique. So those have the unique constraint. And under the hood, that's actually going to create those constraints on the database itself. Now, another thing you'll see is for any given column type like varchar, you might have some options that you can pass in. So in this case, all of these varchars have a max length set to 255. And then, for example, when we're creating timestamps, we can also set the mode. And so this is actually one of the nice things about working with dates in Drizzle is if you've worked with other ORMs, a lot of times they'll parse the date from the database that comes back as a string into like the date object in JavaScript. And that's not always ideal. So if you set the mode to string, you're always going to have it as strings. And then you can use your preferred date parsing library to turn it into a date if you really need to. Now, another thing you see here on the timestamp table is this default now function. And so this is just built into timestamp, and it actually will use the database method for setting a date if we insert this row and we didn't specify a created at or an updated at value. Now, from there, you can see I have some relations down here. We're just going to ignore those for now, because technically, if you're just using the query builder syntax, you actually don't even need to set up these relations. These relations are only needed whenever you're using the ORM style syntax, so we'll talk about that later. Next, let's take a look at defining relationships with a foreign key constraint. And so you'll see on a column, you have this references method. So in our database schema here, let's actually take a look at city and state. So you can see that a city references the state via state ID. So if we look in our codes, we have the state table, which is pretty straightforward. But then if you look at the city table, it actually references that state table, right? So we have a state ID, it's an integer, and we say it can't be null, which means, it must have a reference, and it references the state table ID column. And so this is how we set up that foreign key constraint. The other thing we have going on this table is a composite key, right? So for any given city, it must be unique within that state. So you can't have two cities with the same name. So we have set up a composite key. And so if we look in the docs here under indexes and constraints, you can see how they set up this composite key. Now, it's possible to just create it without a name, and then you just pass in the columns and it'll create that composite key. But you can see that you can also pass in a custom name. So if for whatever reason, maybe if you're creating this from an existing database or something like that, you might actually want to set a custom name, but then we just pass in the columns and we have our composite key. Now let's also take a look at how to set up indexes. So indexes are also constraints, so they appear in that function that you pass in. But specifically for our app, we set up an index on the restaurant table. So we want to be able to query for restaurants by name, and we want that to be fast, so we set up an index on the name column. And so here you can see we just call it whatever we'd like, and then use the index function that comes from PG Core, and then specify the column that you want to index. And that's really the extent of defining your tables. Now, I haven't talked about this yet, but what I really like is that it's actually just done with code. And then the thing that is returned is an actual TypeScript type that we can use everywhere else in our code base. So this is really a really nice code first way of doing this, where we define our tables in this way, but the literal thing that we're exporting here is also the type that we can use everywhere else in our application. So that's a beautiful thing. Let me just show you some of the other tables, but beyond what I showed, that's pretty much it. You know, we have some unique constraints, not null constraints. We have some indices, and then we also have like foreign key constraints. And so I guess I'll show you that order table again, because this one probably has the most relationships. But you can see there are several different foreign key IDs that are set up here, pointing to different tables. And for these, I'm actually importing that specific table into this file. Next, let's talk about migrations. So now that we have these schemas defined, we need to actually run them against our databases, and this is where migrations come in. So you can see in their docs here, they say define your schemas, and then you need a connection file. So this is the same connection file that we're using for Drizzle Studio, but when you're migrating, it's going to use this file as well. So I'll remind you, at the root of our code base, we have our config set up here. And the most important thing is pointing it at the schema and then also telling it where the migrations should go. So specifically in our schema folder, we have an index file that imports all of our tables. And so because this is where we've declared our schema, this is how it's going to know to create all of these specific tables in the migration itself. Now, to generate the migration, you need to run the drizzlekit generate command and then pass in the specific type of database. And so I have added a script to my package.json that does just this. So you can see I have this db generate command that runs that specific command specifically for Postgres. And so whenever we run this, it'll look at those schema files. Any changes that have happened will get added to a new migration file. Now, to actually run the migrations, you just do it with TypeScript code. So there's nothing built into drizzlekit that runs them. You need to specifically create a migration file and then just run that with something like TSX. So let's take a look at how I did that. So if you look in the codes, in the DB folder, I have a migrate file. Now, you can see that I set up this environment variable here, db migrating. And I talked about this earlier, but when we're running our migrations, the connection to our database should only use a maximum of one connection. So that's why I set up these environment variables. So when migrating is true, this connection here is only going to use a max of one connection to connect to the database. So that way we're not trying to create tables in multiple processes. So this script right here basically just throws an error. If you try to run migrations and you haven't set this, it's not going to let you do it because it wants to make sure that it's using a single connection. From there, it just imports the DB and the connection that you're going to use everywhere else in your application. So it's nice and easy. You don't have any duplicate code here. And then the other thing is we want to reuse that configuration for the migrations folder. So instead of duplicating that, we specifically bring in the drizzle config and then just pass in that out value. So that way it's using the same migrations folder. And from there, we just run the file. So if you look in our package.json, we have a db migrate. And specifically, we're setting the db migrating value to true. I'm using cross env, so this works cross-platform. But then it literally just runs that file to generate the migration. Now let's see migrations in action. So right now we have our base table set up, and I highly recommend that you actually don't create any migrations until you have a standardized, stable database structure, because when you're in development, you're going to be changing things a lot, and you don't want to have a bunch of migrations that are just doing development-y things where it's kind of like changing the base structure of your database. So I highly recommend figure out your structure, and then you have a base migration that defines that base structure. But from there, maybe you have new feature requests or new things that you're adding to the app, and that's when migrations are useful. So let's see an example of that. If you look at our existing schema, restaurants have no way of being managed. Like, unless we have some sort of like super admin or like a god mode, there's no way for users to have the privileges to edit a restaurant. So what I want is like a join table, right? I want an owners table where I can have a user ID and a restaurant ID. And if a user is in there, they have the privilege to edit that restaurant and also edit that restaurant's menu items. So let's do just that. In my schema folder, I'm going to create a new file for that table. Let's call it restaurant owner table. From there, our base table setup will look like this. We have the restaurant owner, which is a PG table. We export it, and it has an ID, which is a primary key. Then I'm going to set up the restaurant ID. And so we'll call this restaurant underscore ID, and it's going to be not null, and it's going to reference the restaurant table. So in order to do this, I'm going to need to import that restaurant schema. And then we also need the owner ID, which is going to come from the user table. So I'm going to call this owner ID. And the name here will be owner underscore ID, but this is going to reference the user table. So this is another thing that I'll need to import in. So this looks good. I have basically a join table here that references both of those tables. The other thing I want to do though is set up a composite key, right? Because you should only have one owner and ID. Like an owner can't be an owner twice on here. So let's just set that up here. And we'll just call this the unique owner. And this is going to be unique. And so we'll pull that in from PG Core. I want to point out that this is something you need to be careful of whenever you're working in your schemas, because there's these other libraries we could potentially import in from. So don't make that mistake. Make sure that you're importing from the correct library whenever you do that. So should you be unique on, and then I'm going to pass in both of those columns. So I'll say table.restaurant ID and table.owner ID. Great, this looks good. So I've defined my table. Now I need to pull it into my schema. So we'll go back over to our index here, and I'm going to import it in. So here I have export, the default export from restaurant owner from that specific restaurant owner schema. Now from there, we can actually generate our migrations, right? Because we've added a new table, so we're going to expect that the migration that gets generated adds that new table. So let's see it in action. And so from the command line here, I'm going to do an npm run db generate. And so that's going to look at the existing schema, look at the changes that I've made, and then generate a migration file. So if we take a look in that migrations folder, you can see that it creates the table if it doesn't exist, and then it adds all of our constraints. This is also one of the beautiful things about Drizzle as well. These migration files are extremely readable. And so it's also a great way to learn SQL DDL syntax if you're not even familiar with that, because it's very straightforward, right? It's creating the table, adding the constraints, good to go. But now that that migration exists, we need to run it against the database to actually create that table. So we need to run the migrate command. So far we generated the migration. Now we need to actually run migrate, which is going to create that table on the database itself. So if I do an npm run db migrate, that then looks at that migration file and runs it on the database. Now, the reason we're seeing all of this SQL output is because in my Drizzle instance, I have logger set to true. So you could set up another environment variable for this, but for now I just have it so we can see the stuff that's happening behind the scenes as well. Now let's take a look at seeding the database. Now, just like migrations are literally just a TypeScript file that needs to be run, seeds are the exact same thing. So seeds aren't built into DrizzleKit. You just literally write a TypeScript file that seeds your database. So I created this source db seed.ts file. And then in my package.json, when I do a db seed, we set our environment variable db seeding to true, and then we just run that file. So let's take a look at how I actually run these seeds. Now, just like migrating, I check to make sure that we're in seeding mode, and otherwise I throw an error and the seeds don't run. So seeding needs to be set to true specifically. So we have some connection options that get set whenever seeding is set to true. So if it's true, we have a single connection because we need to create these seeds in the correct order. And then also I'm hiding any notices that pop up because I'm doing some table truncation. So let me show you that. So whenever you seed the database, you basically want to start from scratch. Now, technically you don't need to do this. I am doing some SQL raw here to do a truncate and restarting the identity. Technically, you could also just do a delete all the rows in the table, but that won't reset the primary key on the table. And there's reasons why you may or may not want that. But specifically, because we're in Postgres, I can run this truncate command. So it specifically wipes out the table and it restarts the ID. So every single table is always going to start with an ID of 1 after these seeds are run. So I run over all of my tables from the schema and reset them. Now, the order here is important. Now, technically, because we're doing Cascade, You won't run into as many issues because it actually will delete the dependent rows in the other tables. But if you didn't have a cascade, the order is important because you need to delete in the order of things that are not dependent on each other. So that's another thing to take into account. From there, we also need to seed our data in a specific order. So the way that I have seeds set up is in the seeds folder, I have a separate file for each of the tables that I want to seed. And so let's take a look at the category seeds. It's pretty simple. I export a function that takes in the database connection, and then we just do some inserting. So the way insertion works with the query syntax here is you do db.insert, you pass in the schema, and then you pass in some values. And you'll notice here I'm just using JSON files. So if we take a look in the data folder, I have categories.json, and these are just the basic categories that get inserted in. And so for simple lookup tables like this, it's super easy, right? You literally just insert the data itself. But when things are related, it gets a little bit more complex. So for instance, let's take a look at the city table. So all three of these tables, category, status, catalog, and state, those are all lookup tables, so they're not dependent on any other tables. But the city table is dependent on the state table. So for these purposes, the state table needs to be inserted and seeded first so that when we're inserting cities, we can relate them back to the state table. And so let me show you how I do that. If you look in my data folder, I've got the cities.json. And you can see that I'm just referencing the state name. Now, state name doesn't exist on the city table. During my seed, I need to actually look up the ID of the state based on its name. But by structuring my seeds in this way, I don't have to know the ID ahead of time. So even if I wasn't restarting the identity, I would still be able to seed this table. So let's take a look at the codes for that. And it's literally just some SQL code. So iterate over that array. And then for each one of them, I need to find the state with that specific name, right? So we grab the cities from that JSON file for each one, find the state that has that specific name. Now, in this example, you actually can see me using the more ORM syntax. So I'm using like find first, and you're seeing a first look at how we actually do where statements. So equal actually comes from Drizzle ORM, and it's how we do these comparisons. So I'm saying the state.name column should be equal to the state name string that comes from that JSON file. So we look up the state in the database, and it should exist because we seeded the state table first. And then from there, if we didn't find it, I just completely exit and stop seeding because there's an issue with the data that we're seeding. But if we did find it, we then return it. We set that state ID, so that way when we're putting it into the database, it has the actual ID of the corresponding state. From there, we just have an array of insertable values, and then we just use the query builder syntax to insert all of those cities. Now let's take a look at restaurants because things get even more complex. So first I'll show you the data. If we look in the data folder and then restaurants.json, you can see that for each restaurant, it has its basic info, but it also needs to reference the city table, right? So a restaurant actually has a city ID. So it's going to be a similar idea here. For every restaurant, we're going to need to look up that city by name first to grab its ID. From there, I want to insert menu items for this specific restaurant. And so I actually have these embedded in this JSON file here because a menu item needs a restaurant ID. And so my seeds are basically going to have to find the city, insert the restaurant, get back the restaurant ID, and then insert menu items with that specific restaurant ID. So if we look at the restaurant seed file, you can see just that. So we pull in the list of restaurants, and then for each of those, we first need to find the city. If we didn't find it, we just stop seeding because there was an error in our JSON data. We then now have the city ID, and we can actually insert that restaurant into our database. From there, we use returning, so that way we have access to the inserted restaurant, and then we can use the corresponding ID whenever we're inserting these specific menu items. Now, you'll notice this gets even more complex because a menu item has a category, and so we need to look up the category ID. So I have a little helper function here that looks up the category ID by name, returns that category ID, and then we can use that when inserting the menu item and also the restaurant ID. Now, similar ID with users. Users have an address. So if we look at the data for users here, we've got some user info and then a list of addresses. So we need to insert that user and then get back the user ID, then insert the address. So let me show you that. And also we need to hash the passwords when we're inserting them into our database. So let's look at the user seed. For every user, we insert them into the database. Now we're giving some default values here, like yes, the email is verified. Yes, the phone is verified. But we need to hash these passwords before they go into our database. Now, The way you hash the password is going to be dependent on what you're using for your auth provider. But in this case, we're just assuming that the actual application code that's going to be verifying these hashes is also using Argon 2. So I'm pulling in the Argon 2 library to hash that password before it goes into the database. From there, we get back the user ID, and then we can use that user ID when inserting into the address table. But again, there's another nested relationship because an address also needs a city ID. So we do a quick lookup on the city name to grab the city ID. And that's our seeds. It's a lot. I highly recommend look at the link in the description. You can peruse through this code and kind of like dive a bit deeper. But the beautiful thing about this is I can start my database from scratch no matter what. So let's do just that. I am going to kill this Docker container and then remove the DB data, which is where all of the Docker container data is stored, and then do a Docker compose up. Now I have a completely fresh Postgres database. There's no data in it. There's no tables in it, nothing at all. And so we've started from scratch, but we can still get back to where we were because we have migrations and we also have our seeds. So from here, let's do an npm run db migrate. And so that's going to take all of our migrations and run them against our database over here. And then we can run the seeds. So if I do an npm run db seed, that's going to look at all of our seed files and then insert all of that data into the table. And we still have Drizzle Studio running. So if we take a look at Drizzle Studio, you can see that all of the data got inserted here and we're good to go. And the nice thing about the way I've set up these seeds is we could run these as many times as we want, and it's going to work every time because it's literally emptying out the tables before it happens. So I could run the seeds again, and everything's going to be just fine here because of the way that I'm resetting those tables. And actually, let me show you what would happen if we didn't do the truncation. So right now, for instance, you can see categories start with ID 1. So 1, 2, 3, 4, 5, 6. And similar for like cities and states, because we're restarting that identity, their IDs start over. But if we didn't truncate the table, we actually could just do a delete from on that row. So if I do a db.delete, we pass in the table name. So now this is just going to do a delete star from table. But because this isn't doing truncation, that's where the order actually matters here, but it's still going to work because of the way that I set this up. So now if I change that to delete instead of truncate, watch what happens with the IDs. We'll run these seeds again, runs just fine. But if we look back in Drizzle Studio, the IDs have not been reset, right? So like our category IDs are now starting at 7 and our city IDs are starting at 7. So depending on your application, you may or may not want those IDs to always reset. But because of the way I've set up these things where each of the individual seeds are doing lookups instead of just having a hard-coded ID value, it still works and we can reseed our database no matter what, and it all connects together. Now let's see what it looks like to actually query the database. And for this, I am using a library called typedrpc, so I can have a very simple setup for a server and a client. So again, it's super simple. Literally all I have is a little Express API that has this service here. The service just exports a bunch of methods where I can actually query the database. And then the client-side code just gets a nice little typed client based on that API where I can call those methods and then get back to like typed data from those methods. So let's take a look. The first query here is just getting all the categories from the database. So this is using the more ORM-like syntax. So whenever you import your database connection, you're going to have access to this query thing, and then you have access to all of the tables that you set up on your schema. And so you can access any one of these, and then there are two methods. There's find many and find first. And so the ORM syntax is only for querying the database. There is no ORM syntax for actually inserting into the database, but it works just like this. So query, table name, find many, that's going to return everything from the database. So if I run this codes, I can do a dev for my API, that'll start up my API server. And then if I want to run the client, I can do an npm run dev client, that'll just run it and then spin back down. So that queried all of the categories from the database. Now to see this same thing with the query builder syntax, we can see that we do a db.select. And so db.select will specifically do a select star from table. You can also pass in like column names, but in this case, we just pass in the table name. And so here you just do db.select from and then pass in the specific table. And you can see that I'm importing that table from my schema. So it's the same typed exported value, and then we just can query from it like that. And so in the client side codes, it'll look the same, but we just say get category select, And the data that we get back is going to be exactly the same, but it's just using that query builder syntax instead. Now let's take a look at related queries. And so in this case, I want to get a list of all restaurants, but I also want to include the state information and the city information, because a restaurant has a city ID, but we want to actually have the city name, so we need to query that table. And then a city has a state ID, but we actually want that state name, so we're going to query that table as well. So because I've set up these relationships, we can query it in this way. So we can say select from the restaurant table, but include the city's relations, and then also include the state's relations. So let's take a look at what this looks like. So when I run this query, it's going to give me back all of the restaurants, but then you can see that they have a city property, and then that has the city information. And then from there, that has a state property with all of the state information as well. Now, to set this up, you do need to set up relations. So let's take a look at that. If you look in our schema, first of all, on the restaurant table, you can see that I have restaurant relations that I'm exporting as well. And I set up city, and then also menu items, which we'll talk about later, and also orders. Now, this city relationship is a one-to-one relationship. So a restaurant has one city, and you can see that I do need to be explicit here to specify, well, what's the column that it's coming from. In this case, it is the city ID column. And then what table does it reference? In this case, it references the ID column in the city table. So that makes it so that we can query to get the city information whenever we're specifically querying a restaurant. But if we want to get the state information, that happens inside of the city table. So if we look on city, city has a relation to the state table, and it references one state. Similar idea here. And so because I've set up those two relations and I've exported them. So if you look at my main schema export, I'm also exporting the relations. So that way, when the schema gets loaded in, all of those relations get added in as well, which allows us to query in this way. And so I'll actually show you this. If we comment out those specific relations queries, you're going to get an error from Drizzle that says it doesn't have enough information. So if we remove the city column, then Drizzle no longer knows about that relationship. Now, it still technically has the city ID column, but we do need to be explicit about how that relationship appears. And you can see the moment I've done this, we actually get a type error. And so now, whenever we're trying to find here, it's saying may only specify known properties. And so because we haven't set up that relation, it doesn't know about querying that nested relation there. So these relations absolutely need to be set up if you are doing this ORM-like syntax. Now, the other thing I want to show you is the actual SQL query that gets generated when we run this. And so I showed this earlier, but because we set logger to true in our Drizzle instance, you can see that it actually spits out the SQL query. And the beautiful thing is this is a single query to do all of those nested relations. So you can see here that Drizzle has actually created a nice single succinct query to get all of that related data. So we're getting all of the restaurant columns, but then we're doing a left join. And then because we're using Postgres, it actually can do a JSON build statement. And so this is actually specific to Postgres, and that's how it's getting those nested properties. So honestly, I think this is a great way to even learn about SQL. If you look at the actual queries that were executed against the database, you can learn a lot about how to query in this way. Now let's look at an example of a where clause. So in this example, I want to get a restaurant from my database with a specific restaurant ID. And so I have a where clause, and I want to look at that specific ID. So I showed a few examples earlier when we were looking at the seeds, but this equal function here comes from Drizzle ORM. And we basically say on the left-hand side, what is the column we're looking at? And so we specify the schema.column name, and then the value that we're looking for. And so that's going to set up the correct where clause under the hood. And then again, we have some related queries here to pull in all of the related data. So let's say I want to grab the restaurant with ID 17. I'll run that codes here, spits it out. But you'll notice because of that related query, we're actually including menu items, but then we have the restaurant info here. Now, let's take a look at this same query, but instead of using the ORM syntax, we're going to use the query builder syntax with just left joins, right? So in this case, we're going to select from the restaurant table. We have the exact same where clause. And so that's the nice thing about both the ORM syntax and the query builder syntax is the way that you specify wheres are almost exactly the same. And then we can do a left join. So because I want to grab all the menu items for this specific restaurant, we do a left join where the menu items restaurant ID is equal to the specific restaurant ID that gets returned. And similarly, we want to return the category of these items. So we're going to return where the category ID of the menu item is equal to that specific category ID. And so if we run this query instead, We get back the data, but you'll notice it's in a slightly different format. And really, this is just the nature of querying with joins against your database. Because when you do a left join, and also like a left join on multiple tables, it returns a row with duplicate data for each item in that result. So because we queried this way, we actually have a duplicate restaurant for every single result that came back, but we have not only the restaurant, then we have the menu item, and then we have the category for that specific menu item. And so when you're doing left joins, you get back all the data you wanted, but you are getting back some duplicate data as well, which is why those ORM queries are much nicer. But if you look at the SQL that was output from this, it's fairly straightforward because it's literally just like left join stuffs. And so in this case, we're just selecting a bunch of columns, doing 2 left joins, and then we're good to go. So because we're not doing any sort of like JSON aggregation or anything like that, the SQL query is fairly straightforward. But again, you are going to have some duplicate data in the output that you'd have to iterate over. So in this example, we're grabbing a restaurant by ID, but we're only including menu items that match a specific category ID. So you would potentially need to look up the category IDs and then pass in like the ID for like desserts or something like that. But we can get more complex than that. So this query says, give me the restaurant with this ID, but only show me the menu items with this specific category name. And so because of this, we have to do a lookup to find the category ID, but we can do that within a nested statement. So right here, we say, grab the menu items where the category ID is equal to the ID that is returned by looking up that category name. So this is a nice nested select statement that actually gets compared here. And this whole thing gets run as a single SQL statement. Now, another interesting query we could do is, let's say I want to find all customers that have ordered from a specific restaurant. So here's what I do. So I want to find all users where their ID matches the ID from a specific order. So we're querying on the order table where that order belongs to a specific restaurant, the one that we're looking for. From there, we're going to select the user ID, and then any user that matches, we're going to return them. And from there, we're going to get back also the orders that correspond to that user. So basically, in a single statement, we have all the users in our database that have ordered from a specific restaurant, and we have the order that they made at that restaurant. And then the last really complex one I have here is I want to know all menu items in a given city that are of a specific type. So like, give me all the dessert items in Denver or all the dinner items in New York. And so this one gets fairly complex. First of all, give me all menu items where the category ID matches the category name that we're looking for, right? So I have this nested SQL statement here. We're looking up the category ID. We want to match against that. So this will be like the ID for dinner or the ID for dessert or something like that. Okay, so there's that. We're combining this with and. So match the specific category ID, and we want to find a restaurant that exists in this specific city. So we'll start in this nested query here. So we're trying to find the city ID based on the specific city name that got passed in. So that's going to give us the city ID. Then we're finding all restaurants that exist within that city, getting back their ID. And then we're saying, make sure that the restaurant ID of the menu item matches against that. And then we're including all the nested data there. So this is a fairly complex query with like deeply nested SQL statements as well. But let's actually just run this one because it generates a single SQL statement for all of this, even with all of the embedded stuff. So here I'm saying, give me all desserts that exist in New York. And let's run the codes. And it's done. So you can see we have a chocolate brownie from the Central Park Cafe. It's in that desserts category. We're also including like the city information and I think also the state information. And if we look at the generated query, it's a bit of a beast, but it is a single query, which is fascinating. So let's actually take a look at this as well. But again, honestly, like to me, this is like a learning opportunity. Like, what are these queries that Drizzle is generating? And they're actually like extremely readable too, right? You have this like JSON build array, you have these nested select statements. So honestly, this was fun for me to even just see the very readable SQL queries that Drizzle generates. Now, that's all I have to show you, but I highly recommend take a look at the code, dissect it, learn from it, and then also let me know if there are issues with it or things that you would change about it. But yeah, like I said, this code is open source. You can see how I did everything, how I did the seeds, the migrations, how I set up the schema. And if you have any questions, let me know. So throw it down in the comments. And also you could open an issue on this GitHub repo that's linked in case you have a question or you find an issue. I do want to mention there's a lot more you can do with Drizzle as well. So they have a whole section on performance. You can also do like prepared statements, and they also have transactions. There's more advanced stuff you can do as well. And there's also a built-in Drizzle Zod library. So this is something I didn't get to demonstrate, but for any of your tables, they have a way of generating a Zod schema for both inserting and selecting. And so this is something that's so common that you do when you're dealing with a database. You have a specific data access layer and data access object for like querying the database, because when the data you get back from a database, for instance, is going to have an ID on it. So that's one specific schema. But when you're inserting into the database, you typically don't insert with an ID. So that's a completely separate schema. But this is just built into Drizzle Zod. So you can actually generate these schemas, define them in the same file, and now you have all of your types that have a single source of truth. Like all of your types for querying and inserting, and the schema for the table itself just has that single source of truth right there, which is also a beautiful thing. All right, that's it for this video. Hope you enjoyed it. Hope you learned something from it, and I'll see you in the next one.